So, if you've ever worked with serverless, you know that little bit of magic you feel with your first AWS Lambda. But what happens when that initial magic turns into a really tangled mess? Well, we're about to unpack that whole journey, from one simple function to a super complex system, and we'll explore how to scale without, losing our minds.
This right here, this gets to the absolute heart of the issue. Your first function? It feels like a superpower. It's fast, it's cheap, it's easy. But as you start building more and more, that beautiful simplicity can start to hide a growing tangled complexity. Pretty soon, you're not just adding features, you're adding risk. Risk to your application's stability, and frankly, to your team's sanity. So let's just rewind for a second, back to the beginning, the serverless dream. Why do we all fall in love with this approach in the first place? It really all comes down to a simple but really powerful promise of being able to focus on just one thing.
I mean, the appeal is so clear, right? You only pay for what you actually use, server management just completely vanishes, and scaling, well, it's automatic. You can go from an idea to a deployed feature at lightning speed, focusing only on the code that actually matters. This is totally the honeymoon phase of serverless development.
And then success happens. Your application gets popular, your traffic spikes, and all of a sudden that beautiful, elegant architecture starts to creak and groan. The dream can very quickly turn into a bit of a nightmare.
So let's ask that question directly. What happens when your user base just explodes? Well, the very things that made Lambda so attractive in the first place, that automatic scaling and its on-demand nature, can ironically become the biggest bottlenecks. The cracks really begin to show.
And these are the warning signs you'll start to see. Your users start complaining about slowness, you start seeing these strange timeout errors in your logs that you can never seem to reproduce, and when something does break, it's an absolute nightmare to try and trace a single request across a dozen different functions. This is that moment where you realize you've got a problem.
So what's causing all this? Well, the first culprit is the infamous cold start. If a function hasn't been used recently, AWS basically has to wake it up and spin up a whole new environment. That little bit of setup time adds latency, sometimes seconds, which for a user waiting for your app to respond is an absolute eternity.
The next issue is something called concurrency throttling. So AWS puts a safety limit on how many instances of your function can be running at the exact same time. When you hit that limit during a big traffic spike, AWS simply starts rejecting requests. Your application effectively has this hidden ceiling on its performance that you might not even know is there.
And finally, there's service sprawl. I like to call this death by 1,000 microservices. You have hundreds of tiny little functions all calling each other. The architecture diagram starts to look like a bowl of spaghetti, and eventually no single person on the team really understands how the whole system works anymore.
Okay, so that's the problem. And I know it sounds a little bleak, but it's not hopeless. The key is to recognize these patterns and start refactoring for resilience. It's time to start taming the chaos.
You know, a really simple design principle can make a huge difference here. A lot of us start with these big monolithic lambdas that try to do everything. The fix is to embrace focus. Break them down so each function has one job and does it well. This makes them way easier to test, to reuse, and best of all, it isolates failures.
So, here's an actionable playbook. First, group your functions by what they do in the business. Their domain, like authentication. Second, decouple them using an event bus, which lets them communicate indirectly instead of through all these fragile direct calls. Third, centralize your configuration. And finally, standardize your logging. This is how you start to bring order back to the chaos.
Let's go back to cold starts for a second. Look, you can't completely eliminate them, but you can manage their impact. You can actually pay to keep a certain number of your functions warm and ready to go. It's a feature called provisioned concurrency. The key here is to apply this strategically, only for your most user-facing, latency-sensitive functions.
And to fight that service sprawl, you've got to get your configuration under control. Stop putting settings and environment variables scattered across hundreds of functions. Instead, use a centralized service for all your parameters and secrets. And treat your infrastructure and configuration just like code. Version it, review it, and automate it.
Testing. Oh man, that's another huge pain point. Trying to mock every single AWS service locally is just a fragile nightmare. The modern approach is to shift your strategy. Sure, do your basic unit tests locally for business logic, but run your big integration tests against real temporary infrastructure up in the cloud. It's really the only way to be truly confident your stuff works.
So, after all this refactoring, you might reach a final, really critical question. Is Lambda even the right tool for this anymore? This brings us to the final stage of our journey, knowing when it's time to evolve beyond a purely Lambda-based architecture.
And you know what? The honest answer is no. Serverless is a spectrum of tools, and Lambda is just one of those tools. Forcing every single task you have into a short-lived, event-driven function, that's a classic architectural anti-pattern.
This table is a great way to think about it. If your workload needs to run for longer than 15 minutes, or if it requires really consistent performance without any cold starts, then a container-based solution like AWS Fargate is often a much better fit. It just gives you more control for those long-running or really heavy workloads.
The truth is, the most mature serverless architectures are rarely pure Lambda. They're hybrid. They use Lambda for its strengths, handling all that spiky, event-driven traffic. And they use containers for what they're good at, those long-running, predictable background jobs or services that need consistent performance. It's all about using the right tool for the job. And that right there is the ultimate takeaway. Don't measure your success by the number of functions you've deployed. Measure it by the resilience and the maintainability of the system you've actually built. The goal isn't more Lambdas. It's a system that works, that scales, and that empowers your team.